In this video, we will use SERIESSUM and LINEST in the Maclaurin series expansion of cosine and its polynomial regression. Let's generate the dataset of the cosine, which is our formula, cosine of the x values. We can chart this and regress it to the best fit trend line. So we regress it to the best fit trend line, and we use polynomial show the equation. We make sure that the r squared is 1, making its perfect fit. So we 2, 4, let's raise it to the power 6. Now we have a perfect 1, r squared. Next, we enter this time we will calculate the expansion, the Maclaurin series expansion of cosine. It is equal to the summation of x to the power 2n times the coefficient, where it is equal to negative 1 to the power n over 2n factorial. The values of n will be from 0 to infinity. And x will be raised from 0. That's 2 times 1 is 2 times 0 is 0. So x to the 0 is 1. And the next level will be 1. 2 times 1 equals 2. So x squared, then x to the fourth, and so on. So that's why we have series sum of x to the 0 incremented by 2 and the coefficient. The coefficient can be calculated using RA formula. Let's start with the numerator. Negative 1 to the power n. Then we add the denominator. Factorial 2 times n. And we enclose that the whole fraction as part of the RA formula. Now we have the coefficient. This time we generate the dataset for the Maclaurin series expansion, which is RA formula, series sum of the x values raised to the power starting with 0 incremented by 2 and the coefficients. This value same as this value. This is the function, and the expansion are the same. We can show that in the chart. We add this to the chart. So edit chart, add a series, and this will be the series to be added. You will notice the blue datasets are covered by the red datasets because they're the same. And we'll show the trend line using the same format, that is polynomial raised to the power 6. And we'll show the equation and r squared to find out if the regression coefficients are the same. Yes, the regression coefficients are the same for B0, B1, B2, B3, B4, B5, and B6. We'll calculate these regression coefficients using LINEST to get their accuracy. So to do that, we have to complete the 1 comma x matrix from the x1 column, then the x to 1 column, x squared, x fourth. So we generate the power. So transpose up to 6 because we're up to the 6th degree. We're calculating from up to the 6th degree. So this is RA formula of the x values raised to the power 0. And we lock, that's the 1 column of the 1 comma x matrix. Then we lock the references to calculate the x column, which match to our x values. And then the x squared column, and then x cubed column, and the x fourth column, x to the fifth column, and x to the sixth column. Now we have the 1 comma x matrix. We can use the LINEST of the function itself. That's data y. and dot x. And for the expansion, which is LINEST of data y and dot x. B0 may not be exactly the same, but when rounding up, they are both 0.996. B1, they're the same. B2, they're not exactly the same, but if you round it up, they are both negative 0.489. B3 is 0. B4, they're not exactly the same. There's a bit of an error, but when you round it up, it is 0.372. B5, they're 0. And B6, they are both negative 0.815 times 10 to the minus 4. This completes the use of series sum and LINEST in the polynomial regression of a Maclaurin series expansion of cosine.